Imagine you're on a ship sailing through vast seas, where storms and waves constantly attack and test the will of those on deck. On these giant ships, hundreds, even thousands of sailors are facing danger day and night. Especially on Navy aircraft carriers, which carry up to 90 fighter jets worth tens of billions of dollars. That's the reality facing US Navy ships, braving sudden storms and massive waves to keep crews and priceless assets safe. How do these ships handle big storms with rough waves? Life on the open ocean is fraught with danger, a far cry from the tranquil harbors that we're accustomed to. Weather is one of the main factors that makes the seas more harsh and dangerous for US Navy sailors, who often conduct missions that last for months. Wind, which plays an important role in shaping the weather, creates powerful ocean currents, which determine the intensity of ocean waves. Winds can reach speeds of more than 60 knots, creating giant waves up to 300 feet high during a storm, enough to swallow an entire ship. These waves not only put pressure on the ship's structure, but also reduce maneuverability, increasing the risk of capsizing. Faced with the mighty power of the ocean, sailors must constantly fight to keep their ships stable and safe. Thousands of sailors are constantly at risk with their ships becoming unstable at sea. When heavy equipment and machinery are on the ship and it's displaced, it not only endangers the crew, but can also cause serious damage to the ship. Although the US Navy has implemented many advanced safety measures, Mother Nature is still an unpredictable opponent. The strategy of the SSL Pharaoh on October 1, 2015 was a bitter reminder of the devastating power of nature. The ship disappeared with 33 crew members after facing Hurricane Joaquin, and all search and rescue efforts have been fruitless. Since such heartbreaking incidents, the Navy has continuously improved safety by adopting modern techniques and better designs. But what the next perfect storm comes, will those measures be enough to protect it? Before discussing the advanced technologies that help warships cope with extreme weather, imagine trying to balance a pencil on your fingertip. Now try doing it on a roller coaster. It's the complexity and sophistication of naval engineering that enables warships to overcome the challenges of the rough ocean. Let's analyze the important factors that help US Navy warships maintain balance and prevent the risk of capsizing. According to basic laws of physics, an object will float with its average density and lower than the density of water. Similarly, ships float because their density is lower than water, allowing the buoyant force from the water to be greater than the downward force of gravity. Another important factor is the location of the center of gravity. The lower the center of gravity, the harder it is for the ship to capsize. Therefore, US Navy warships are designed with a low center of gravity, by placing heavy equipment, machinery, and fuel in the lower part of the ship. Every arrangement, from machinery installation to equipment layout, is carefully considered by the ship's engineers to ensure stability, helping the ship stand firm against all challenges on the ocean. Another important factor is the hull structure and design. The hull is designed in a large U-shape to enhance stability, minimizing pitching and rolling when moving through rough seas. For larger ships, such as aircraft carriers, the V-shaped hull allows them to cut through large waves effectively, while smaller ships may be more affected by wave height. In particular, US Navy aircraft carriers use ballast systems to maintain balance, similar to the way the scales of justice work. The crew can adjust the ship's center of gravity to control buoyancy and keep the ship stable in all conditions. In addition to these basic designs, the US Navy also integrates many advanced technologies into its warships to ensure safety in the most extreme weather conditions. Among them, fin stabilizers are an important technology, which act like flaps on an aircraft to maintain stability and maximize the effectiveness of the ship's weapon systems. These stabilizers counteract the constant rolling, helping the ship maintain a stable and accurate launch even in rough sea conditions. Without them, carrying out sustained attacks would be nearly impossible beyond calm seas. With fin stabilizers, the US Navy warships become more powerful and precise, better meeting the mission of maintaining freedom of navigation globally. A prominent example of innovation in naval engineering is the gyroscopic stabilizer, a modern technology that enhances the stability of ships. Similar to the way a bicycle tire keeps the bike upright while spinning, a gyroscopic stabilizer uses a vacuum sphere containing a flywheel that spins at 10,700 RPM. The rotation of the flywheel creates angular momentum, which in turn generates torque that helps keep the ship stable. The system is computer-controlled, automatically adjusting the tilt of the gyroscope to optimize performance in different sea conditions. Furthermore, the development of autonomous ship technology has brought about significant improvements. These ships are able to right themselves after capsizing thanks to a special design. Smaller vessels, such as RHIBs or rigid hull inflatable boats, can automatically return to a stable state after a sudden capsize. In rough sea conditions, these vessels are often equipped with weight systems, bilge water tanks or angled hulls, which create the necessary torque to resist capsizing. When a capsize is detected, the ship's onboard computer immediately activates pumps to transfer water between tanks, helping the ship to quickly stabilize again. For the US Navy, regular maintenance and testing of these technologies is critical to ensuring safety and effectiveness in harsh marine conditions. To ensure warships operate efficiently 24/7, regular maintenance is extremely important. The team of engineers and sailors must perform maintenance work to promptly detect and resolve potential problems, from cleaning, painting, repairing to upgrading equipment. Maintenance is divided into two main types: preventative maintenance and corrective maintenance. Preventative maintenance, also known as planned maintenance, aims to prevent problems before they occur. Tasks such as machine lubrication, fluid testing, functional testing, and vibration measurement are necessary measures to ensure any system operates stably. The goal is to ensure every detail, from nuts to bolts, is properly inspected and adjusted to avoid problems. Meanwhile, corrective maintenance is only performed when the ship has encountered a problem or is damaged. This includes repairing and restoring damaged equipment, avoiding facing high emergency repair costs at sea. In this way, preventative maintenance helps control operating costs and reduces the risks of catastrophic failures. In addition, ships also need to be maintained through processes such as dry dock maintenance and overhaul. Dry dock maintenance helps inspect and maintain submerged parts such as the hull and propeller by removing the ship from the water. Meanwhile, overhaul maintenance involves disassembling, inspecting and repairing and reassembling various ship systems. For the US Navy, maintaining ship systems in perfect condition is critical to ensuring ships can effectively deal with harsh sea conditions and unforeseen challenges. Weather forecasting is a vital element in ensuring maritime safety, especially for the United States Navy, where sea conditions can change suddenly and severely. To meet these challenges, the US Navy employs advanced weather monitoring and forecasting systems to help adjust course and navigate ships through rough seas. In this field, satellites play an essential role. Specialized satellites orbiting the Earth collect data on clouds, air, water temperature, ocean currents, and other meteorological phenomena. This information helps the crew predict and monitor weather conditions on a large scale, thereby planning and adjusting the itinerary accordingly. Besides satellites, weather buoys are also indispensable tools. With more than 1,000 weather buoys distributed globally, they provide vital data on wind, waves, atmospheric pressure, and temperature, helping to predict storm formation and other weather conditions. The US Navy also uses powerful environmental models such as the Hurricane Warning Center and Triple Wave Warning models, integrating data from multiple sources to provide accurate forecasts. Navy warships are also equipped with modern weather measuring equipment, including anemometers, barometers, and weather radars. The US Navy's navigation system not only orients ships, but also optimizes speed and course to minimize the effects of rough sea conditions. While advanced technology plays an important role, we cannot forget that the true soul of the Navy lies in the brave and dedicated crew. They are the ones who are really responsible, and the safety of the ship depends on their skills and preparation. Therefore, training is an integral part of ensuring optimal performance in extreme conditions. The crews undergo a rigorous training program designed to prepare them to deal with extreme weather conditions. They learn techniques that can be the difference between life and death in emergency situations. During the exercises, crew members perform important exercises such as damage control, which helps them respond promptly when a ship encounters problems. They're trained to handle situations such as water leaks, equipment failures, and other situations that could threaten the stability of the vessel. These skills are vital in maintaining the safety and stability of the ship in the face of great challenges. Evacuation drills prepare for a situation where the ship must be abandoned, when the risk becomes too high. The crew is taught how to lower lifeboats, don life jackets, and collect necessary survival equipment. At the same time, overboard exercises equip crew members with the ability to perform rescue and first aid when a crew member falls overboard in rough sea conditions. In all of these emergency procedures, establishing effective communication is essential to form coordination with other crew members. Additionally, they must remain vigilant around the clock as they constantly monitor weather forecasts and sea conditions. Their keen observation and decisive decision-making skills help them make timely and important decisions that determine the fate of the ship. Modern advances and future improvements with advances in science and technology, naval engineering continues to evolve at a rapid pace, poised to transform the future of naval vessels. Let's take a look at some of the modern advances and future improvements that the US Navy is currently exploring. First of all, the US Navy is gradually adopting the use of lightweight composite materials for shipbuilding. These materials not only reduce the overall weight of the vessel, but also maintain structural integrity and provide better corrosion resistance. All of these things work together to prevent capsizing. Also, let's talk about something that's not so common: virtual reality training for crew. Remember that crew training is vital to ensuring the stability of the vessel in rough seas, as a small mistake can escalate the situation in an instant. So, with the help of virtual reality training, crews can experience realistic simulations of various sea conditions, including turbulent weather and deadly storms. It helps crew members develop effective decision-making skills and practice crew coordination, which is vital for effective teamwork. The US Navy is stepping up research to develop adaptive hull surfaces and can flexibly adjust to sea conditions. Yes, these surfaces will be able to change shape based on the ship's speed and the turbulence it encounters. This not only contributes to keeping the vessel stable in rough waters, but also improves hydrodynamic efficiency, resulting in reduced fuel consumption and enhanced operational performance. Additionally, one of the promising advances in the integration of artificial intelligence into ship stability systems. With the ability to continuously analyze sensor data and adjust stabilizers in real time, AI can perform complex calculations on the fly to respond to extreme conditions. The future is approaching when US Navy ships will be equipped with self-learning systems that can predict and prevent capsizing risks, contributing to increased safety and operational efficiency of the fleet. These technological advances promise to change the way the Navy operates in the future, and we look forward to seeing what comes next. So have any of you, current or former sailors, experienced a hurricane on a naval ship? How does it feel? We look forward to hearing your stories and experiences about those special situations. Please share your insights and memories in the comments section below. Finally, thank you for watching our video. If you found it useful, please like and subscribe to the channel to update the latest videos about the US Navy. Remember to click the bell so you don't miss any content, and see you in the next videos.